morning, or good afternoon, or good evening, or whenever you're deciding to watch this video. Today's lesson is on the classification of matter. Matter is the stuff of which all materials are made, anything that has mass and takes up space. So we learned last week that anything that has mass is called its mass, and anything that takes up space is called its volume. And if we compare those two things, mass to volume, we get the density of the subject or the object, which allows us to identify it because each material has its own unique density. Matter is made of atoms. Atoms are the extremely small building blocks of matter. It's really difficult to think about something so small that makes up everything we can see and feel around us. But it's important to try and practice training your brain to do that, to think of everything you look at as being made of billions and trillions of these tiny particles called atoms. All matter. And remember, matter is anything solid, liquid, gas, or plasma is composed of these atoms. And those atoms, while they are made of other things, can't be broken down into their smaller pieces by chemical means. So an atom, we will find, has smaller particles in it that we are aware of and we can predict the behavior of, but taking those particles apart is not possible at this point. The smallest distinct units in a sample of matter is known as the atom. And when we talk about elements, we're talking about anything that is made up of the same atom. So atoms come in different sizes. The particles that make up the atom come in different numbers for each particular type of element. So when you have an atom that has a certain number of the particles that make it up, then we say that that atom is distinct to this particular element. And an element is anything we can find on our periodic table. Elements cannot be decomposed into other substances. So if you take an element like oxygen, or lead, or tin, or helium, or nitrogen, or anything on our periodic table, if we break apart the individual atoms in that element, it does not turn into something else. So when we discuss elements, we talk about pure substances. Pure substances are also known as elements. They are composed of identical atoms, so every single atom in that substance, and here we have copper, and here we have aluminum, every atom in those are the same. That makes them pure. A molecule is a combination of two or more atoms. Those atoms can be the same type, or they can be different types, that are covalently bonded. Bonded just means chemically joined together. And a molecule is the smallest particle of a substance which exhibits the physical and chemical characteristics of that substance. So then there are some things, like water, where you can't break them down into atoms because then that would change the substance that it is, but you can break it down into molecules. So a molecule of water is the smallest particle of water that still behaves like water and has all the physical characteristics of water. We talk sometimes about diatomic molecules of elements. These are things, there's a limited number of them. These are things found on the periodic table that are always found in molecule form. You never find a single atom of these things. Most of them, not all, but most of them are gases. So hydrogen, oxygen, chlorine, nitrogen, fluorine, bromine, and iodine are your diatomic molecules. So these elements are always found in pairs of atoms. As we continue to look at pure substances, we can also talk about compounds. A compound is a molecule that's composed of two or more elements in a fixed ratio, such as what we see here, salt. The properties of each individual element are different from the properties of the substance or the compound that we typically see. So, table salt is composed of sodium, which is Na, and chlorine, which is Cl, and those two things have very different properties from what you put on your corn on the cob. Sodium and chlorine are both, when you look at them separately, those elements are both poisonous gases. And you can see here, salt is not poisonous. We eat it all the time. And it's also not a gas. So by combining these two elements, we get something totally different, and it's called a compound. For example, we have two different compounds pictured here, and when we see models like this, diagrams like this, each sphere represents a different atom. So in this case, carbon atoms are green, oxygen atoms are red. And even though both molecules are made of both carbon and oxygen, when you change the number of the carbon and oxygen, you get two different compounds. So in our first compound, carbon monoxide, which is a poisonous gas, you have one carbon and one oxygen. In the second compound, carbon dioxide, you have one carbon and two oxygens, which is what we breathe out every time we exhale. In continuing about compounds, there are slight differences in combinations of atoms can have a large difference in their properties. H2O, for example, we know is water. Two hydrogen atoms combined with one oxygen atom. If we add another oxygen, we get hydrogen peroxide, something that you might use to clean out a cut. If we add some carbon to the compound, C2H6O, we get ethanol, which is something you can drink. But if we change the number of oxygens in this compound, we get ethylene glycol, which is poisonous. So there are a couple laws that we need to discuss when we talk about compounds. First, the law of definite composition. This means that a given compound always contains the same fixed ratio of elements. So H2O, there are always two hydrogens, always one oxygen. And then the law of multiple proportions, which means elements can combine in different ratios to form different compounds, such as the examples we just saw on the last slide. Pure substances have the same kind of particles throughout them. Pure substances can be compounds like water, or they can be elements like copper. Compounds, if they are pure, can be decomposed into simpler substances by chemical changes, but always in a definite ratio. So we can break apart a water molecule into its hydrogen and its oxygen. An element cannot be decomposed into simpler substances by chemical changes. So an element such as copper, if we just cut smaller and smaller pieces of copper, we would still have a bunch of atoms of copper. Even if we tried to get down to one single atom, we can't do that other than just by cutting the physical thing that we can see. So we've talked about pure substances. Now let's talk about something that's not pure, like a mixture. Mixtures have two or more substances that are not chemically combined. They're just kind of next to each other. And again, we're kind of thinking in really small terms here. Mixtures don't have a fixed composition. There can be more of one substance in the mixture than others. They don't have constant melting points or boiling points, which are physical properties that we will discuss later. And basically saying the same thing as here, mixtures don't have a fixed composition. That means their composition is variable. It can change. Components in a mixture retain or keep their characteristic properties. They can be separated into pure substances by physical methods, and mixtures of different compositions may have widely different properties. So let's dig into this a little bit. Looking at these diagrams, in the first one we have atoms of an element. So notice that all of the spheres running around here are the same thing, and they are not physically joined or chemically joined to anything else. So that would be an example of an element. If we move on to molecules of an element, you'll notice that, again, the spheres are all the same color, but they are joined with another of the same color. So this would be a molecule. Here's an atom by itself. Here are two atoms joined together. That's a molecule. Since there are no other colors mixed in, these are both elements. If we have two different atoms that make up something, then it becomes a compound. So here we have atoms that are joined together, so that means this is a molecule, not a single atom. And since there are two different colors, that makes this a compound. But this compound is still pure. If we look at all the things in the box, all the things in the box are still the same. We still have one purple atom joined to three green atoms. And finally, if we go to the last box, we have a mixture of elements and one compound. So put all of these things together, put A, B, and C together in the same container, maybe, then you get a mixture. This is pure, this is pure, this is pure. This, not pure. Here we have an element, here we have a molecule of an element, here we have a molecule of a compound. So it's important that you study this diagram because you're going to be identifying mixtures and compounds based on pictures just like this soon. So let's practice. What is this? If these spheres represent atoms, what do we have here? Well, notice they're not joined to anything else, and there's no other type, meaning color or shape, in there. So this must be an element. Single atoms, all of the same type. What do you think this is? Now we have two different kinds of atoms, and they appear to be joined together or bonded. But if we look at the mix as a whole, all of the things here are the same. So if we are joining elements together, it's called a compound. And since there's no other compounds there, we leave it as a compound. This last one, we have things that are not joined together, not bonded, and things that are not the same. That makes this a mixture. And this would be a mixture of two elements. No compounds in this particular mixture, no molecules in this mixture. So we talk about mixtures, and we talk about that they are able to be separated apart. You can separate the different things from each other. There's ways to do that, or techniques to do that. First, you can do it by eye, which means if you have a bag of M&Ms, you can physically separate the different colors of M&Ms from each other just by looking at them. You can filter, or filtration, to separate a solid from a liquid. For example, if you have a mixture of sand and water, you can filter the sand through something like a coffee filter or a strainer and separate the sand from the water. Distillation goes a little step further. This is when you have something with two liquids bonded to, or mixed together with different boiling points. You can boil one off, which leaves the other one. And finally, something called chromatography. I just read a recent article about what chromatography is used for in the real world, and it is amazing. It's used in making perfume, it's used in making medicine, it's used in all kinds of things. But chromatography is separating pure liquids or solutions of compounds by basically letting things separate out through a filter kind of paper. You know how when you put a paper towel into water, the water kind of rises up the paper towel or climbs up the paper towel. That's basically what chromatography is. So we've talked about pure substances. Those would be elements or compounds. Now let's look at mixtures in more detail. Mixtures are a variable combination of two or more pure substances. They can be either heterogeneous or homogeneous. Heterogeneous means that the things that make up the mixture are all mixed in. You can see the differences between the things that make up the mixture. This is probably a piece of granite, and you can see all the different minerals that make up the granite because of the different colors. You've got a homogeneous mixture. This looks like some apple cider, where you can't physically see the difference in whatever's making up the apple cider. So matter can be broken down two ways, either pure substances or mixtures. Mixture is a physical combination of two or more substances. Its composition is variable, which means it doesn't always have to be the same. The properties of mixtures vary according to what it's made of, and the components can be separated by using physical means. On the other hand, pure substances, there's only one substance present, whether it's an element or a compound. It has a definite and constant composition. It's always made of the same thing in the same numbers. And the properties are always the same under a given set of conditions. So let's take a look at some examples. Graphite is an element. Pepper, on the other hand, is a heterogeneous mixture. So it's made of different things, and they're not all in the same ratio. Sugar is a compound. So that means it's made of different elements bonded together, but all in the same number. Paint is a heterogeneous mixture. And soda is a solution, which is also a type of mixture. So if we look at just mixtures, we can break those down into either heterogeneous or homogeneous. Heterogeneous mixtures have two or more visibly distinct phases, so you can see the difference between the things that make up the mixture, and each phase has different properties. Homogeneous mixtures has only one visibly distinct phase. You can't see with your eye, you can't see what makes up the mixture, and the phase has the same properties throughout. Homogeneous, one phase, uniform properties in a sample. Same composition. For example, if you mix sugar and water, once the sugar is dissolved, you can't tell that there's sugar and water just by looking at it. Heterogeneous mixture, two or more phases. Each phase has different properties. So if you look at a bag of M&Ms, you can see that there are two or more distinct things in there, and each one has different properties. So in this case, different colors. Another example would be oil and water. If you shake up a bottle of salad dressing that's made of oil and water, you can distinctly see the differences between the oil and the water, and then if you let it sit, it separates out. Sand, same thing. You can shake it up, but when you let it sit, you can see the separate particles of sand and water. So let's put all of this together in the same flowchart. When you are asked to classify matter, ask yourself first, can it be physically separated? If the answer is yes, it's a mixture. If the answer is no, it's a pure substance. Then ask yourself, if we look at pure substances, can it be chemically separated? If the answer is yes, it's a compound like water. If the answer is no, it's an element like aluminum. Once you know you have a mixture, we can go on this side and say, is the composition, or is what it's made of, is it uniform throughout? Is it the same throughout? If it's the same throughout, you can't look at it and tell there's a difference. It's a homogeneous mixture. If it's not the same throughout, it's a heterogeneous mixture. And then these can be further separated into colloids and suspensions, which we'll talk about, but you don't need to memorize. So, mixtures, solutions. These are homogeneous. So small. The particles are so small that you can't tell them apart just by looking. It does not have a Tyndall effect, which the Tyndall effect is if you put light, which you can see here, if you shine light through it, it kind of scatters the light, so you can, it makes it opaque, if it does have a Tyndall effect, but solutions do not. You can't tell by shining a light through it. And the particles don't settle out. For example, rubbing alcohol is a mixture. A colloid, on the other hand, heterogeneous. These particles are medium-sized. It does scatter light when light is shown through it, but these particles don't settle. So milk is a colloid. You can't see the different particles settling in milk, but it is made of different particles. And then a suspension goes one step further. Heterogeneous large particles, you can see them sometimes. It does scatter light, and for example, fresh squeezed lemonade, if you let it settle, you can see the differences between the water and then the other components that make up the lemonade, like the sugar and the lemon juice. So here are some other examples of mixtures. Mayonnaise is a colloid. Muddy water is a suspension. Fog is a colloid. Salt water is a solution. And Italian salad dressing is a suspension. But again, these terms, it's good to know, but you don't need to know. So let's practice classifying matter. Atoms and molecules make up all matter. All matter exists as substances that are pure or mixtures. Pure substances can be elements or compounds. Mixtures can be heterogeneous or homogeneous. Elements have all the same atom, and you can't break those atoms down into anything else. Compounds do not have all the same atom, and they can be broken down chemically into their separate atoms. Homogeneous mixtures have different atoms that are not joined together by bonds, and heterogeneous mixtures have different atoms that are not bonded together, but they're also not necessarily in the same ratio. Take a look at our diagrams here just as one more chance to practice. This is a microscopic view, so if we could actually look at atoms, an element would all look the same, but they would be separate from each other. Diatomic molecule would all look the same, but there would be pairs. A molecule of a compound, everything in the box would look the same, but it would have two different types of atoms joined together. And a mixture of elements and compounds would have everything in the same box. So to practice, classify the following as element, compound, or mixture. Air is a homogeneous mixture. A tin can would be an element. Windex is a homogeneous mixture. Suntan lotion is a heterogeneous mixture. Oxygen's an element. Sugar is a compound. Crude oil is a heterogeneous mixture. And gummy bears are homogeneous mixtures. Then we have problem 2. A white solid is dissolved in water. The resulting colorless, clear liquid is boiled in a beaker until dryness. White crystals remain in the beaker. The liquid can be classified as, so here's what I notice. First, they could be separated physically. This would be through evaporation or distillation. So that makes it a mixture if it can be separated. We're left with two different kinds of things. Whatever evaporated, and then these white crystals which we could not see before. If we couldn't see before, then that makes it homogeneous. Now it's your turn. If you need to look these things up, go right ahead, use your resources. I want you to classify the following as element, compound, or mixture, and then tell me whether that's heterogeneous or homogeneous. If you have any questions, please let me know.